Hello and welcome. This is Jim Kaufman with Rankin Technical College. So what we're going to cover today in this video is kind of a continuation of what we did in the previous video. So in the previous video, besides just the lecture itself, I went ahead and went through a couple demo apps that are somewhat similar to the homework lab assignments. Okay. So as far as those demo apps, let me bring that up. So here is the GitHub repository where I have those. Okay. By the time you watch this video, I'll have this updated with all of them. I don't have them all here. I just have kind of, I think, what we covered yesterday. So by the time you see this video, you'll have part 1 and part 2. Part 1 will have 3 of them, and this just has 2. It'll have 3 of them, and then the part 2 will have 5 of them in there. Okay. But I did want to just show everyone, especially the newer students who haven't done this much, about cloning a repository. I know you did it the first time, but one time's not enough to really learn how to do it well. So I'll give you this link. I'll send you an email, send everybody an email with this link. And if you come over here to code, and then you need to make sure you got HTTPS click, not these ones, right? HTTPS, and then there's there's the URL to the GitHub repository. Click copy to clipboard, and then if you bring up your GitHub desktop, when you bring it up, you'll probably have some stuff you're working on or whatever, but you can come up here to File and do Clone Repository. Okay. And then here you can, and here you want to make sure you're on URL, right? Not GitHub.com or Enterprise. You'll make sure you're on URL here, okay? And then you just want to paste that URL in here. All right. Let me check real quick. You want to make sure, though, choose a directory where you don't have anything. You don't have your other, don't accidentally put this in the directory of your coursework, okay? Make sure you're in a separate directory outside of that. And I'm going to check mine real quick here. So obviously, you can choose your path. I just went and looked for where I wanted to go. I'm copying that in there. So this is where I'm wanting it to go. And I'm going to go ahead and hit clone here. And then obviously it'll clone your directory, okay? And I did want to show you something else as well. So like if you're working on your assignment, you want to kind of see what I did in the demo one, which is obviously going to be different than your assignment, but there's some similarities there that you can kind of look at and could help in some ways. So as far as the code itself, as far as creating the win forms and the designer thing, that should be a little more challenging. You can have more than one open, but use a lot of resources and stuff. But if you want to just look at the code in something separate, right? If you did download that Notebook++, what you can do here. So I went ahead and cloned my repository. I have it now. Obviously, I can show it in Explorer. Oh, and it's popping up in this other window. So on here, though, what you can do here is you can go, if you just want to look at the code, okay? I wouldn't use this to edit anything, but you can come here, and it's always going to be the form, whatever the form you name. Usually it's, if you didn't change the name of it, it's going to be form1.cs. I created, this one I have movie rating. So if you right click on this one and then edit in Notepad++, and you bring that up, so here's the form. So here's, that code, the CS form. So this can kind of help you a little bit, okay? So you can have this up. You can be looking at this. Just another option. Obviously, you can have multiple Visual Studios open, all right? But, it just takes a lot of resources. So whatever works best for you. Just showing you a different option. All right. Okay, let's get rid of that. I think we're done with that as well. Okay, so back to this. So what I went over in the previous video, I did a loan approval app demo, right? And this one had both a credit score and an income, okay? And kind of somewhat similar to for what your homework assignment is, you have a GPA and a mission test, okay? But a lot of the same concepts are being used, right? So for your GPA and emission test, you're going to be doing those ands, right? You're going to be doing the comparables, right? Um, the conditionals, I'm sorry, the conditionals. So you're going to want to check if GPA is 3.0 or higher, right? And the emission test is 60 or greater, right? Same thing as I did on my loan approval. I did if the credit score is 700 or higher, right? So that means 700 credit score is 700 grade or greater than, right? Greater than or equal to 700. And, right, the double ampersand and the annual income is 40,000 or greater, right? And obviously, I'm not going to look at we're going to look at the code again, just kind of a quick review. And so then the next one here was the hurricane one for your assignment. And the one I did here was kind of a movie rating classifier, right? So here you've got your different categories, and based on that, you're going to go ahead and display what kind of category it is. And in my case, I've got a movie rating where I'm displaying if it's must see, excellent, good, average, etc. Right? All right, but them are already out there in the repository, and like I said, by the time you see this video, all the others will be too. So the third one is a rock paper scissors. Okay, but I have a demo coin flip game. It's going to be either heads or tails. Right? You're going to have 3 of them. I just have 2. But I'm going to go ahead and go through the code that I created for this coin flip game. Okay. What I'm not going to do, because there's a bunch of different ones here, I'm not going to kind of go line by line with the coding, but I am going to discuss the code. So I already have it coded and ready to go. And then I'll just talk about different concepts within the code, the demo code. Okay. Another thing I wanted to mention, so if you're just like in your directory structure, because sometimes you're going to start having multiple labs. I know you can go into Visual Studio and select the ones in the list, but sometimes that can be kind of confusing too, and you get too much stuff in there. I showed you also how you can right click and remove it from the list. But if you've got it in your directory structure, okay, you can always come into a Windows Explorer window. And anytime, anywhere you see the solution file, right? It's going to be SLNX. You can double click that, and it's automatically going to bring up your application in Visual Studio. So I do that often. I do that when I'm grading all your different assignments. So, okay, so this one here, let me go back to that requirements doc real quick. So in here, for my coin flip game, like I said, it's going to be heads or tails. So for mine, 1 is heads, 2 is tails, my demo. For your assignment, you're going to have rock, paper, and scissors. So rock is going to be 1, paper is going to be 2, scissors is going to be 3. And so the whole objective of this lab is you're playing against the computer, right? You're going to choose rock or paper or scissors, and the computer is going to be picking one as well. So you're basically competing with the computer to see who wins, okay? And the way we actually do this, how the computer will pick one of these, right? We don't hard code that. We use what's called a random generator, okay? And in this case, this random generator for the rock, paper, scissors, it's we'll look at the code for the demo, but this is what you'll do to create a new random generator. And then you do what's this dot next, okay? And here you'll see it's got a 1 and a 4. And so what this kind of means is start at 1, okay? But your upper limit, I know this is a little confusing, your upper limit is 4. So basically, when you say 1 or 4, you mean 1, 2, and 3. Okay, that means your upper limit is 4. You can't go, and so it's 1, 2, 3. I know it's a little confusing, but that's how it works. For mine, I'm actually, if you'll see over here on the right hand side, mine's going to be 1 and 3. So I'm going to be doing 1 and 2, 1 for heads, 2 for tails, right? So mine's 1 dash comma 3, whereas this one, since you're doing 3, you need 1 comma 4. Okay. And let's see what else. That's about it. And like I said, I've kind of already created the code, so let's watch it work. We'll just do it first, and then I'm going to review some things in here. Okay. And hopefully these still work when I'm out here playing around. So here you can choose heads or tails. Okay. So, I kind of made them a little different, put some, made them bigger, right? You can make them bigger. So I made them bigger and, put a little different color text just for fun, since it's kind of a game, right? So here I chose heads. The coin landed tails. That was what the computer, based on that random, it came up with tails, right? So I was wrong. My score is here. I'm going to do tails this time. I was wrong again. I'm going to do heads this time. Oh, I'm not doing well, am I? Computer scores 3. Wow, finally, I got one right. All right. I'm going to go over here. Wow, I've got 2. Who won? So I did 5 rounds. I think your assignment says 3 rounds. I did 5 rounds. So in 5 rounds, the computer won, right? So, okay. And actually, I think that I see kind of a bug there, but that's okay. Heads, computer won there. Ooh. Computer won again. So, something to play with. All right. So in the code, right, we've got, I did something a little different. It's kind of a little bit ahead of where we are. We're going to be doing soon. We're going to be doing methods. We're going to learn about methods. But in this designer, I went ahead and let's bring this back up. So obviously, I click on this and over in the properties window. I don't know why that is being a little funky here on me today. I have never seen that happen before. Okay. For now, I'm not going to worry about that right now. So in here, basically, I have the heads and I tails, right? All these buttons. I have a button click events on each one of these, right? But over here, so I have a button click event for each one. So in the button heads game, right? So if they click heads, if you click, the user clicks heads, right? It's going to first ask if the current round is greater than or equal to the max rounds, right? Okay. If it's not, then you can go ahead and start, right? Play the game. And it's going to pass in heads, okay? Heads. So if not, then we kind of go ahead and disable everything because that means you're basically done, okay? The current round and the max round. So what we do is we kind of go ahead and define all this up top, okay? Since we're, when you do a button click, and we did a lot of our code within a button click, all of the code you create in there, all of the variables you create and all of that, once that method's finished, you're done, right? That variable is not available anymore. And for us, since we're clicking like a heads or a tails, we're clicking a heads or a tails. Once you do that, right, it's gonna execute that method, right, that on click method. But once it's done, it's gonna display on the screen, right? But anything, like I said, you define and there's gone. So for us to hold on to things, right, we have to define them at a higher level. So up here in our class, right? This is a class. We want to go ahead, and this is what you're going to want to do for yours as well. You want to go ahead and define some variables. So here I've got a constant called heads is 1, tails is 2. I have my random generator up here, okay? And then I have stuff I want to track. The only way to track this on multiple clicks, right, is to have, I'm not saying the only way, but for the most part, the simplest and straightforward way is to have these defined outside of your button click events, right? So in this case, you got a player score, a computer score, your current round, and the max rounds, okay? So every round, we're going to add 1. Every time we finish a round, we're going to add 1. And eventually the current round, right, is going to be 5, right? And then we do a check, and that's where we check those in our button click events, right? And if we check that, and once it's done, that's it, right? But like I said, so anything you want to hold on to outside of just a button click, you have to define at a higher level. These are called class variables, okay? So they have class scope. It's all about scope. So the scope within a method itself, so we come down here, so your tails click, the scope of anything in here, like if you defined a variable, right? That's why you can't define all those variables here, because you're going to lose them once you're out of this method. Once you leave this method, you don't have the scope of those variables is gone, okay? Now, if it's at the class level, you can continue with that scope throughout, right? But here we're doing actually a button for tails.click, and then if the current round is not greater than or equal to max rounds, okay? If it's not equal to that, then we can go ahead and continue the game, another round, right? Once that this is not equal to max round, it's not greater than or equal to max rounds, then it's going to fall through this else statement, and it's just going to disable the button heads and the tails. It's going to disable all that, and it's going to enable this new button game, okay? And it's pretty much a exact duplicate here for heads. Heads and tails are the same. The only thing that's different is for tails, we pass in tails, and here we pass in heads. And so where is this, right? This is, this is not a string, right? You don't have like quotes around here. This is the one that's at the top, right? So if I do this and go to definition, it'll go up to the top. Okay, here's your heads, here's your tails, right? These are constants. So these are what you're passing in. So I created this other method, okay? And when I'm passing in is player choice. So this is going to be either when I called game round down below. When I called this, I pass it in either a 1 or a 2, right? A 1 or a 2. And so this is going to be 1 or 2 coming in here. Okay, then we're going to do our generator. Okay, do a next. And like I said before, this is the upper limit. So for us to have a 1 and a 2, for the computer to choose either a 1 or a 2, it's got to either be it's got to be a 1 and a 3, the upper limit, right? So this will be either a 1 or a 2, right? And so this is going to create a coin result. So every time that this method gets called, and it's basically every time you click heads or tails, this game round is going to be called as long as you haven't reached the max amount of rounds, which is 5. Okay? And so this one here is going to end up either being a 1 or 2. It's going to randomly generate this. And so the coin result will either be our 1 or 2. And it's going to check it against our same variable that we created up here top, right? So it's going to check this. Did this, either it's going to return a 1 or a 2. Is this a 1, basically, right? This is equals 1. Is this a heads? Is this a 1? If it is, coin landed on heads, right? Else, coin landed on tails. Then it's going to take my player choice, right? If the player's choice guess was correct, right, that was the one here, right? If my player choice, that's one I passed in, equals the same coin result, right, that the generator created, that means I won. I was correct, right? Not I won. You have to go 5 rounds. But I was correct. If it's not, that means that actually the computer, it was different than what the computer generated, right? So mine was wrong, okay? And then each time what I'm doing, this, a plus plus is called an increment. So this is adding 1 to player score, right? So if I come up here to player score, this is another variable that's outside of the method. The same thing with this method here, right? Once you finish this method, this coin result, you define this here. Once you finish 1 round, because every round you're going to call this. So once you finish 1 round, this is the scope is gone, right? You don't have access to it anymore. This is everything gets redone each time. How we're tracking everything is in these variables, right? So player score is going to start at 0. Computer score stays at 0, right? We do an increment. This is called the increment. So every time we increment it by 1. So the first time, if I won, if I did it and I won, it's going to be 1. The next time I come back over through this, it's already 1 because we saved this outside of this method, right? Everything else in this method's not, is outside of the scope, right? Once you finish it. But player score is defined up top, so we still have that. So next time it'll be 2, then 3, then 4, right? Same thing with computer score, okay? And then what we're doing here is each round we go ahead and update our different labels for text, okay? The player score, computer score, and then it's just current rounds and max rounds. This is just using, remember we've kind of done this different ways, and there's always different ways to do this. Remember the string interpolation where we use the $sign, we put things in the curly braces for strings. You can also do this. This is kind of actually the older way. I don't want to say older, but more traditional way. You just use plus. Now this isn't adding anything, right? This is called string concatenation. So it's taking this string, okay, and it's adding whatever's here, okay? If you don't have a space here, then it's just going to butt it right up against there. Having a space is nicer, makes it easier to read, right? But this is not adding anything. Just want to make sure. Sometimes it can be confusing. Think of this as like an addition operator, and no, it's not really an addition operator, okay? When you're doing it on a string, it's called concatenation, even though that this is a string and this is an integer, right? We define this. Let's go look at it. And this is how you can always do this, right? Right click, right? And then go to definition. So here it is. And this is an integer, right? All right. So yeah, it's clicking to doing all this. Then it's checking if the game is over. It's checking if current round is greater than the max rounds. And then it basically determine. So yeah, so all of this is an if with other else is in here, right? With this is a compound if else, right? This is an if statement, right? There's no else that belongs to this if, right? There's one if statement, and this is just checking. Hey, are we done? Are we finished? Have we reached basically all of the rounds we were supposed to? Is the game over? It's 5 rounds for a game, right? So if the game is over, right, then we see, is the player score greater than the computer score? If it is, then we go ahead and set our label, you win. Else, the computer wins, right? And then this wouldn't even be relevant, but it's here anyhow. This is another else, right? And then basically, so if we changed our thing to, instead of doing 5 rounds, we change it to 6 rounds, then it's possible we could have a tie, right? So that just kind of adds that in case we change the number of rounds. Okay. That's really not needed. And so, you don't have to do all of this for the assignment, right? This is somewhat similar. This should be helpful for you. Obviously, you're going to be doing it a little different. You're going to have 3 different choices. Instead of just a heads or tails, you'll have, you're going to have one for each one, rock, paper, scissors, right? You're still going to do this. You still want to do all of this as well. You want to track the player score and the computer score. So a lot of this will be very similar. Obviously here, like your upper bounds is going to be a 4 on yours, right? Because you're doing 3 of them. This is where it'll be a little different, right? So you'll just, you won't call it coin result. You can call it whatever. It's going to be basically the, rock, paper, scissors result, but whatever. You just call this result, whatever. And then you're going to compare this to if it's, is it rock or is it paper or is it scissors instead of heads and tails. So, okay. But one thing is I kind of did do this as a separate method just because it made a lot more sense. And I know that we haven't really talked about this much, but should be not too difficult. Okay, I think a lot of the other stuff will be more difficult for you. Okay, so this was the third one in the third demo that's related to the third one in your lab assignment. All right. So now I'm going to go ahead and do so here's the ones for part 2. And let me bring up my demo. That's going to be somewhat similar. I need to get this other Word document real quick here. Okay. I did want to mention, I forgot to mention this earlier, so just want to know so there's not a confusion. This demo stuff is just for your own, for your own purposes, just kind of to assist you, things to look at. This is not an assignment. The demo apps are not assignments. You're not doing anything here, okay? So I kind of put that at the top of each one. So the next one here is as far as your lab assignment. So this is part 2, right? This is part 2. And so this one here's test score where you enter different test scores, right? If you enter, it tells you if you enter invalid score. Number of scores 3. Okay, so it's saying up to 3. Oh, so you're going to prompt the user until they enter 999, right? So 999 is called kind of what's called a sentinel. So a sentinel is like something that you use to kind of exit your application, right? Especially like for a prompt application, there's not really, you have to find something to enter. You don't have buttons, right? Can't just close it. You can close it, but to stop if you're wanting to keep entering things and, be able to allow multiple things to be entered and not really, have that as a fixed amount, then you have to find a way to be able to stop it. And that's called a sentinel. And so we'll look at that as well. And sentinel could be anything you want. Here it's just saying put a 999, right? So over here in my demo, that's going to be somewhat similar to this one, is going to be a temperature statistics. So here you're going to enter different temperatures, and it's going to tell it's a valid or invalid. So it's the user enters a temperature inside a valid range of -50 to 150. Okay, and then you can keep on entering it. And this one says a -999, so whatever. I think that's what I have in the code. But this can be anything you want. You can change this to don't have to be a number. It could be a Q for quit. I think later, I have some other ones where I just did a Q. So it can be anything you want. Here it's asking you to use 999. No big deal, as long as you have something to be able to exit the application, right? Okay. And this is going to be kind of your number of scores over here on the left, your lab, sum of the test scores, average, lowest. Kind of, I'm doing the same thing here. Number of readings, summing at average, low, highest, right? Okay. So let's look at the code for that. Okay, and of course, some of these are prompts, right? Consoles. I always call them prompts. I don't know. Console windows. Some of these are console windows. Some are WinForms, right? Actually, some of you're actually doing the same not the same, the same thing from in WinForms as what was defined in the console window as well. So here I am doing, so here, like for these console apps, remember we don't have to worry about, before, kind of the older way to do it is you had to make sure that you had the name of the class, you had the namespace, and you had to have a, uh, a main method and all of that. But the newer way, you don't have to do that anymore, okay, for a console app. So basically, you can just start putting in your code, right? You don't have to have everything in the curly braces, like in a structure type thing. Obviously, you do have to use curly braces when in your own code if you're doing a loop or ifs or else's and everything else. But for a console app, you don't have to have that all in there. Now it's different for a WinForms app because it's just kind of WinForms apps. It's like I've said, there's this kind of wiring that the Windows, the .NET environment does for WinForms. So it has to kind of know what it is. It's all part of kind of a bundle, right? How it kind of bundles that with the designer window and some other configuration files. So that's a little different. But for a console app, you can just start putting in your code. You don't have to have that within a class or a method. So here we've got some variables for tracking our statistics. Here we have a count, we have a sum, we have a min and a max, right? So this is an available method for a max value, okay? And this is a one for a min value as well, okay? So here's our sentinel. Minus 999. I think yours asks for 99. So let me just change that for the heck of it. So here, yeah. So, and the good thing about having like these constants and that, you can change this to whatever. So it's not in your code. I went to look for it in the code. I don't have to, right? It's just checking. It's using this, right? It's using this constant. You can change this to anything you want, okay? Well, in this case, it's an integer. So this would have to be a number. If you wanted this to be a string, then you'd have to change it to a string, right? But yeah, that's the benefit of defining those like that. All right, so valid temperature range. So here's the minimum valid temperature and the max valid temperature, minus 50 to 150, okay? And then also you're not assigning a value here, but you're declaring this value of this one as temperature here as well. And the reason for that is because we've got this while loop, okay? And you can always do this to collapse it. So after this while loop, let's see. And maybe it's going to make me a liar here. Maybe we really didn't have to have that up there. I was thinking, let me see here. Yeah, maybe we didn't. Okay. Let me just take that back. Just forget about that for now. I was thinking if it's defined down here, then you want to have this after that, but it's not. Okay. So here is what's called an infinite loop. It continues until the sentinel's value is entered. Okay. So one thing you have to make sure of is you have some way to get out of it, and that's what the sentinel is for, right? If you don't have something to get out of it, while true, this runs forever. By doing it just like this, it's not like you're saying while x equals, while x is less than 10, right? And then you're incrementing x, right? Then, eventually you're going to get out of it, right? But this is just saying basically keep running this forever, right? Until you break out of it some way. This is how you break out of the loop. So what you're doing is once the temperature, that's kind of a weird thing, just because that's the field. And once you enter the temperature, if that is a 999, right, then it's going to go ahead and execute this line, and it's going to break out of there. So here, I probably should have just actually ran this already. Hopefully this will come up. Please enter a temperature reading. Um, so I'll do 100, and then I'll do 50, and then I'll do 150. I think 150 was the max. And then here, what you need to do, I'm going to do 999. Okay. And once I hit enter, it's going to go ahead and leave that loop. Otherwise, it's going to keep going here, right? And if you didn't have anything, right, any kind of sentinel value, then yeah, you'd have to close the program, right? But this is going to actually give you all. So this will stop it. It's going to print everything out, and then you're done, right? Okay. This is doing a double parse on this. There's probably a better way to do some of this. You're gonna get some warnings here, but that's okay. There's no errors in this, so we're not going to worry about that right now. I'll be happy if we just kind of, can get everything basically working for the most part. And so, if certain things you enter here, you could have a problem, right? If you can't parse this to a double, right? All right. So, and then here is a compound conditional where you're basically saying if the temperature is greater than or equal to the min valid temp, right? And the temperature is less than or equal to the max valid temp, okay? Then go ahead and do what's in here. You're adding one to the count. You're summing up things. So what this sum does, so this just add one to the count, remember? So the count's going to start at 0. First time in, this is going to add 1 there, right? Add 1 to the count, and now it'll be 1. The way this works, so this is another variable that we defined up top, right? So if you always kind of, if you kind of get confused where things are and stuff, you can always do it and go to definition. You're going to go to where it was, right? So you had your count, you had your sum, and all these other ones as well. So what this is going to do, it's going to say, take whatever's in the sum, okay, add the temperature. So if you, let's just say this is your second time in here. First time this is going to be 0. So first time in is going to be 0, right? Add whatever's in the temperature. So like I think the first time I added 100, right? So add 100 and then put that value back into sum. So sum started out at 0. Once it executed the statement, it added this, and it's going to put this to 100. Second time in, right? It's already going to be 100. Whatever the temperature is on the second time in, let's just say it's 50. It's going to add 50 to that 100. Now it's going to, and then add it back into sum, which will now be 150. Okay. Let's see, update min if this temperature is lower. Update max if this temperature is higher. Okay. So this is basically taking the temperature, whatever temperature you came in with, right? And then it's taking this, is this less than the min temperature? Okay. And then, so we're going to go to this definition, right? So this is it. Well, this is just a max value for a double or a max value for a double or a min W. This is actually, okay. You really don't have to worry about that too much. If update max, if this temperature is higher. Okay. And then basically, so like I said, you're going to go in this loop all the way until you put in the 999. So you're going to continue on. Then you'll break out of here. Once you break out of the loop, and obviously it's always nice to be able to go ahead and collapse this. Then you're going to go ahead and continue on here, right? This is the next thing you're going to do in the list. This is all part, especially a console. It's kind of all part of the same code. Whatever comes after that, you're going to execute it, right? Unless it's a method and you have to directly call the method. But here it's just code right after, right in the code, right after in the file, right after your while loop. So this is always going to execute, right? And this is just creating a blank line just for styling purposes. And then you're going to go ahead a number of readings, right? And then you're going to sum the number of temperatures. Okay, so then only calculate the average if we have at least one reading. That's always kind of a good thing to do. Because if not, right, what will happen is if count is 0, you're going to divide by 0, right? And this is going to break, right? I wonder if, I was wondering if it was going to catch that, dividing by 0. Let's just for fun, I just want to run this. So we're going to take our sum and divide it by, let's see what happens on this. So here I'm going to put in 0, I'm going to put enter, and I'm going to put in 999. No valid temperatures were entered. Okay, I don't know. Oh, it's not count. Count's always going to be 1. I'm sorry. I wasn't thinking here. If we have at least one reading. Well, it's possible. You know, it's still possible to get to this. Obviously, you come in, the first one's going to, the count's going to be 1, right? The count's going to be 1. Let me try this one more time. I'm sorry. I'm probably just confusing you. So if we do this, and I come in here, and I just hit the enter key, there we go. That's what I expected. Well, it's failing even before then. That's fine. Okay. I was just trying to get it to fail by having the wrong logic here. It's failing before we even get there, though. Okay. Let me go back down here and fix that. All right. So honestly, you want to go ahead, and you don't have to do it, but it's good practice to go ahead and do, kind of like we did the try-parsing, right? All the try-parse. Pretty much should probably do this for the same way, okay? Because if you don't enter valid data, if you enter a null or something that it can't parse, it's going to throw an error, right? Okay. So that's that one. So the biggest thing in here is you're doing a while statement. While true, you're going to be executing that until you reach the sentinel, right? And then after you finish your while statement, you're going to basically just print everything out. Okay. Go back to the things here. Okay. So the temperature thing is somewhat similar to your test score one. And the next one here is going to, please enter test score. Oh, yeah. So the next one is basically almost the same thing, right? But it's a WinForms app, right? So demo 3, 2 is a WinForms app instead. So basically you just have your buttons and everything else. Let me pull this one up. Close all the stuff. I get too much stuff opened here. Okay, so this is kind of the same thing to a certain extent, right? So you're entering a temperature, and then you hit the enter key, right? And you can just keep on entering them. Let's make sure this works. Sure hope so. Let's see. So let me enter 100, enter, and it's tracking number of readings 1. And let me enter 50. Okay. So it's showing you the highest temperature and the lowest temperature. Okay. All right. And so, yeah, so what, so we don't do anything to, we're just constantly updating it. So you don't have, I do have a reset button. You don't have to have a reset button. Okay. so let's go ahead and look at the code here a little bit. View code. So somewhat similar. So here, though, we're doing a WinForms app. We got our namespace. We've got our class definition. Okay. So here we're wanting to do pretty much the same stuff here, right, as before, right? We're going to define this all at the top, right? This is going to have class level. This has class level scope. Is the correct way to say that, right? Because we're going to update this every time we hit our thing. Otherwise, if we are, every time, I know I'm being a little redundant here, but just to make sure everybody understands. So every time you hit a button here, right, it's going to go execute that on-click event, right? So once it did, anything, all these variables that it had defined in here and everything else, okay, these things are all empty right now. It's showing it on your screen. The only way that you have these is because it's in the class variables now, right? It's up top. So that'll hold on to this data so that every time you do this, it'll execute, right? It's going to execute that method again, but it's going to be using those variables that's defined at the top, right? To keep on adding to it. Number of readings, 2, counting, and everything else, right? Okay. So here we got, hey, button, enter, click, right? So basically pretty close. Most of our code that's already here. Clear any previous error messages. Okay, well, because I do have an error one as well. Error label, error labels are kind of nice. So you can always use, especially if you've got multiple labels for different things, probably should have a separate one just for your error messages, right? So then we try to parse the input. Here we're doing the try parse, okay? Like I said, in that console app, probably really should have done it similar, right? So that in case it can't parse it, then, you can go ahead and set an error on it, right? So this one's saying if not, okay? If not. Try to parse the input. So here, basically the same kind of thing you're doing from validate the temperature is within acceptable range. Is temperature less than the min, or the temperature is greater than the max, right? Which are all defined at the top here, right? If there's an error, if the label error is not equal to null, invalid temperature must be between 50 and 150. Okay. And once again here, we're accept the temperature, update the statistics. We're going to add 1 to our count, and then our sum, once again. So whatever the sum is, you're going to add whatever's in the temperature and add that back into your sum, right? Pretty straightforward on this. I mean, basically if you did the console one, a lot of similarities. It's a little different because obviously you're setting things on labels and all of that, right? So that makes a difference there. And this is clearing. This is nice, so your text temperature, this is a clear or a focus. So clear will clear out the data, right? And this will put focus back into that field, okay? So each time you execute this. And the same thing, and here's just a reset button, okay? We haven't talked about right? We haven't really done much of this, but here it's setting everything back, setting your count. So all these variables, right? Where are these variables defined, right? So within a WinForms app, WinForms only knows about what? WinForms knows about your buttons and your labels and your text fields, the way it's all wired together, right? It kind of knows about all those. That's why you don't have to define this. This isn't at the top of your thing like we do other variables, right? Because WinForms apps, it knows about the labels, it knows about buttons, it knows about all those different controls. There's other ones, right, that we haven't used yet. There's radio buttons, there's check boxes. We haven't done any of those yet. But all of those are all available in any of your methods, right? Any of your methods that are available. But here, it's just good to understand because it really helps you. So kind of confusion stuff here, that you understand that this is where is this defined, right? There's not an int here. There's nothing to show that, so it's not defined here. So where is it defined? We already know, right? It's defined at the top here, right? All right. And then, you're just going ahead and setting everything back to defaults, right? Empty strings. Okay. And you don't have to necessarily do this. I'm just kind of added this. All right. So let me run this again. And let me put in something that won't parse. So please enter a valid number. Sometimes maybe an error message would be better, say, up here somewhere. This is probably bad. So we have a lot, especially if you've got a lot of labels, like this one has lots of labels here, right? When we enter valid data, probably an error message should, maybe put it up here, or, something where it's kind of closer to what you're doing as opposed to here. That's probably not a good idea. So obviously you start entering stuff, good data, then you go ahead and do it. But you still have to see it, right? So this was defined red from the beginning, and so I'll go show you that. I think I already showed you yesterday, but then I obviously reset. We'll go ahead and just get rid of everything, right? Reset everything back. Let me pull up the designer window. It's probably going to be this last one on this list. Another thing we can kind of do, so yeah, if I just selected the last one, that's always a challenge. You can make these longer, especially when that you're going to have long things. You can make these longer, okay? Auto resize, you can choose false for these, right? And then you can kind of make these longer, especially when we're doing what that is, right? So now I'm going to go ahead and save this. Just click out of this. So now if I come in here and if I try to grab all these, it's a little bigger, especially if that the things you're going to display in here are going to be big. And that way you don't have these like that. It's probably beneficial to do that. Just want to add that. So it's easier to grab them, a little bit easier. All right. So what else was in here I want to look at? So yeah, this one I chose the 4 color of red, right? So that no matter what goes in here, it's always going to be red, right? The other ones are just the regular black. So just showing that you can have that defined here, even though there's nothing there. Then if if there's a time that you have an error message that gets, put in there, it's automatically going to be red. Okay. So let me get back. I'm going to close this one. So once again, yours is going to be somewhat similar. You're just adding all test scores where I was doing temperatures. It doesn't ask you to put an error message, so don't worry about that. You don't have to do it. Just it's optional at this point. So I just blew by this other one. So this one here is one, lab 3 here is a program that prompts the users for a salesperson's initial. Okay, so you're going to be entering a salesperson's initial, either D for Danielle, E for Edward, or F for Francis, and a sales amount, right? Then updates the total sales. Then any user can have multiple sales, so you're tracking everyone, right? You're tracking each one. And then if the enter and the user enters 0 for the initial, then the program should display the total sales for each 3. Okay. That's all right. If the user enters an initial other than D, E, F, or Z, then the program should display an error message prompt the users for a new initial. Okay. All initials should be treated in a case of insensitive manner. Okay. Okay. So what that means is basically all initials should be in case insensitive. So that means you can have uppercase D or a couple uppercase E or uppercase F, right? So either or, right? And you can handle that in your code. And so for mine, I have what similar one I have is I have a delivery zone tracker where I'm entering either north, south, west, north, south, or west, and I have Q, right? I have Q. So if they enter Q, it will go ahead and print everything up. Okay. Q's my sentinel, right? So here is the tracker, delivery tracker. So once again, we're using a console app for this one. So we are defining some variables at the top that we kind of want to change as we're going through our loop here. So we got a north, south, west. We have a zone, and then we have miles. So that we can hold on to all those variables. So when we're done with our while loop, we can print out things. It's pretty much the same thing here. We're just doing a right for which zone for delivery, and for north, S for south, W for west, and then or Q to quit it. And so what we're doing here, because one of the requirements says to all initials should be treated in a case insensitive manner, and I have that also on this one as well. So somewhere in here, there, all initials should be treated as case insensitive, right? So now we can just, it's a way to do that. I mean, it could be to lower or upper, right? So we're just taking whatever someone entered in the zone, right? And the zone is what we're reading, right? So whatever they entered, we just go ahead and it's another danger here. Really should have probably be doing a try parse on this, kind of like what we did before. So if someone, enters, it's not part of the requirements here, but just mentioning it. But if someone enters something that can't be, parsed, right, it won't work, then, that's going to be a problem, right? But we got a zone, you enter a number, you can't do a too lowercase on a number, right? So, but here if you enter, north, south, west, or a Q, right? If it's uppercase, it will go ahead and convert it to lowercase and put it back in here. Then you can go ahead and start doing your checks. So you got a bunch of different if statements here, right? So, and it's always probably best to do something like this so you don't have to check everything else, right? Here, because you got these others, why even check it first? It doesn't matter necessarily, but this is a simpler check, I guess. From a memory standpoint, maybe a little, it's negligible, but here you're checking for all these different things. Is it this one or this one or this one? Well, if it's a quit, then if it's a Q, we're breaking out of here. We're done. No reason to do anything else, right? So first is checking for a Q. If we have a Q, then we'll go ahead and break. Okay. If not, then we're checking to see if it's an N or an S or a W. If it's not one of those, and you can always kind of collapse those if you need it. But basically, you know, for this if, and always remember when you got a, you know, a curly brace, you have to have the end curly brace. You know, always, you know, these are things, especially early on, it's so easy to miss these, even after a long time, honestly. So, you know, make sure you got, if you got an open parentheses, you have to have an end parentheses. If you have a beginning quote, you have to have an end quote. Okay. Um, you have to have things in here. So here you got zone. Well, this has to be defined, right? So we have this defined at the top. We defined it right here, right? No, it's up here. I'm sorry. Yep. So wherever you've got a type, right? To define a variable, you always have to have a type, either being a double or a string or an int, right? So you know whenever you're looking at something, well, this has got to be defined somewhere, you know, and then you can go up and look, okay, no, it wasn't defined here either, right? You have to have it, you have to have a type, right? So where was it defined? It was defined up top. And then always remember, we talked about this already. So you have an assignment operator and you have equality operators. Equal, equal, two equal signs, right? That is an equality operator. So you're checking to see if the first operand, it's called an operand, is equal to the second operand, okay, of your conditional, right? This is called a conditional, right? And here's your conditional thing. So it's either, you're going to either have ors or ands, right? Um, one thing I haven't done much of. So we did look at this a little bit about the pattern matching. And let me just bring that back up real quick. So that was in the quick guides. And so that was the quick guide number 5, right? Let me bring that back up. So I'm just showing you different things, just while I'm here. Let me just search for it easier. So pattern matching here. So here you're going to, instead of like is not null, right? The other way to do this is the other way to do this would be the exclamation point equals, right? That is not null, right? Is not null, right? Equal equal, if you want to check is null, would be equal equal null, right? But so here you can go is not null. Or if you wanted to check if it's null, you just say message is null, right? So you can use these is as well. This is a pattern matching thing. And you can try it out. I do suggest that you try to be consistent. You know, for now, if you just want to try it on a different one, that's fine. But as we go along, just it's best practices. You know, you don't want to use this way to do this and that way to do that, all within the same code base. You know, if you want to try it out for now, that's fine. Okay, but just a recommendation. You probably should try to be consistent on that. So here, so I'm saying if zone is n, I can do the same thing here, and this would work as well. Okay, obviously it's not complaining anything on that at all, right? But I'll go ahead and put it back the way it was. I just wanted to mention that that is an option. I don't know why I put and there for some reason. Or a. So zone is n, zone is s, right? Actually, got too many options nowadays. Kind of like everything in life, too many options. Used to, that wasn't available. You always had to do it like this, make things easier. You got to get confused, especially you start looking at different code and say, well, that's different than what I'm used to, right? So it does adds a little complexity sometimes to understanding. But so here you're doing a try parse on your user input, right? And our user input we're getting from the read line, and we're using our out variable. So once again here, you're trying to parse you're trying to parse a variable, right? Try to parse a string, and you're trying to parse it to a double, right? If you can successfully parse it, if it successfully parses, it will put that into a variable called miles, right? and then you can go ahead and use it from there. So here we're doing add miles in the appropriate zone. So if the zone is N for north, north miles plus or equals. So once again, whatever the value is in miles, it's going to take the original value of north miles. So if this starts out to be 0, it's always going to start out generally to be 0 in the beginning. Obviously, you iterate multiple times this loop, it's going to change, right? So north miles is 0. You're going to go ahead and add miles to it and put that value back into north miles. Okay, do the same thing for south, etc. Right? And just as a review, so if you do an if statement, if this executes, since you're doing it, you have an else here, this never executes, right? Doesn't even look at this. I don't even say execute. Doesn't even care about this line. Doesn't even, read this line. If this is true, if this statement if this conditional, okay, it's going to return either true or false. Remember, all if statements are always going to return true or false. If you have compound ones, right? So this basically doesn't say all of them. If any one of these, right? A double pipe is or, right? If these were two ampersands, that would be and, right? So this, if either any of these conditional statements, this is a compound conditional. If any of these return true, right, then it's going to start executing what's in that if block, right? So once again, so if this conditional here returns true, it's never going to read these other ones, right? And you should probably write your code. Sometimes you can do this, like if you actually didn't have these else, this would still work fine, right? Because if you entered N in your console window, if you entered an N, it would come in here, and then it would execute this. It would execute this line because this would be true. Then it would come here, and if this was not an else, and let's just say this was another if, right? If this was just another if, it's going to test this. This would not be true. It would not execute this, but it is going to read this, right? It is going to read this. But this is just a little cleaner and a little smarter as far as code. And obviously, small little programs like this, it doesn't matter. But you have some complex ones. You don't want to be reading a bunch of stuff you don't need to be reading, right? You don't. So, like I said, if this is true, it's just going to execute this, and after this, it's going to fall through to the next line, right? And it would fall down to just creating a blank line is what it's doing here. And this else, you always have to make sure things are lined up here, right? So this is closing something, right? So if you just highlight that right there, let me close this, get a little more room here, and close all this stuff. So, and then you probably don't see it very easily. Oh, you probably can see it a little bit, maybe. Depends on after this is recorded. But, you remember the little dimple here, the little part that sticks out, whatever you want to call it here on the curly brace. So you don't want to be on this side because it's not going to tell you what matches. But it's when you click on that side, it's going to highlight a little bit, right? And then plus you got this little line, but, you kind of travel this all the way up. But you'll see this is highlighted, right? So you always have to make sure that, you have things, that you have an N for every beginning one, right? And it's where you expect it to be, right? So once again, this is kind of a compound if-else statement, right? So none of this is ever going to be executed unless this is true, right? Unless this is true. If you had a not sign here, you had the exclamation point, this would not execute unless all of this returned false, right? But that doesn't make sense for us, but in our case, we want this to be true. We want that we successfully did a parse of the user input. We put that in miles, okay? So then we can use that variable now, miles, in our code, right? And then obviously, since we have, if this is true, what's going to happen here? This is not going to be executed at all, right? Nothing's going to happen here. And so that's all part of our while loop. So let's close that. So obviously we're going to continue with our while loop, entering N, S's, and W's until we decide to enter a Q. Once we enter a Q, right, then we're going to leave our loop. We're going to break out. Remember, you have to use a break for that. Okay. And so once we do, it's kind of helpful sometimes. I don't know if you find it helpful, but I like to collapse things sometimes just to see where things are. So after this, it's going to fall out of this loop. It's going to start, this is a prompt, right? This isn't in a method or anything. They're just statements that are right after our while loop. So we start executing this stuff, right? Once we break out of that while loop, right? So we're going to total up our miles. We're going to grab north miles, south miles, and west miles, right? And obviously, like I mentioned multiple times, for us to access these can't be these can be changed within our while loop, but they can't be defined in our while loop, right? Because after we leave our while loop, we won't have access to them. We only have access to something that was defined, in this case, pretty much at the top of this file, right? We defined all of those. So basically, we're calculating everything. We're adding these all up, and we're putting the value in total miles, right? And just I mentioned this already before, but just to mention this again. So obviously, when you're using numbers, right? So this is these are all defined as doubles, right? When you do a plus sign, you're adding them, right? You're using mathematically adding, right? But once again, when you do it this way, right? We could do this way, or the string interpolation, where we use our $sign, right? And we use our variables within the curly braces, right? So that was one way. The other way is to use concatenation, and this is called string concatenation, right? This is adding this string with this string, right? And so this is taking our variable, which is defined as a double, right? That's why we have to do a two-string on that, right? And you were using the formatting of F1, right? These are the formatting things we've gone through before. Maybe we should look at that again real quick. All right. So for that, just to review here. So this is in the, this is actually the console fundamental one, which was the very first one on the guides. And so here's different formatting, right? Formatted output. And so here, if you use like C2, right, that's going to be currency, right? Here's number. Number is going to be like N2, right? If you want 2 decimal places, right? Fixed point is F2, percent, decimal. We were looking at F's here, right? So this one's going to, if you have F2, right? In this case, if you use F2, that's going to be 2 decimal places. F3 is going to be 3, right? But F's are for fixed point, right? For numbers, you use N for number, F for fixed point, C for currency, C for currency. And that was kind of pretty much the same there. So, okay. And so then here after that, we go ahead and determine which zone had the most. So if north miles is greater than or equal to south miles, and this is kind of, there are some better ways to do this, but that's okay. This is a way to do this. So if north miles are greater than or equal to south miles, and north miles is greater than west miles, right? So if basically it's saying that north is the most, so if north is greater than both south and west, right, then the north zone has the most. And then you're just doing the same thing here for south, and the next thing for west here. Well, it's doing it else. And this is always good practice too. No reason to do the same thing for west here, right, as you did for north and south, because if it's not north and it's not south, then it's going to be west. So you just do the else here, right? If this, right? So once again, you're doing this one. If this is true, if this is a compound conditional, right? Compound conditional because you got an and between two different conditionals, right? And then, so if this returns true, it's going to go ahead and execute this, and it falls through all the way down here to line 87. It's not going to do the other. If it's not true, it's going to go ahead and do this one. It's going to check this one. If this is not true, then it's going to go to your else. Okay. So let me just go ahead and run this real quick. So here we're doing N for north. So let's go ahead and put a capital N, make sure it works. So it should be case insensitive, meaning that, it doesn't matter if you put in uppercase or lowercase. How many miles was delivery? Let's put in, say, 800. And then here, so this is why you kind of put those extra lines, just to kind of make things a little more readable. You don't have to, and then I'm going to put a capital S for south. And I'm going to go ahead and put like 1200. And then I'm going to put in a capital W for west. And I'm going to put in like 1600, whatever. All right. And so it's going to keep asking, obviously, until I decide to quit, right? So I'm just going to do it one time. And I'm going to put in uppercase Q. I did not put in an uppercase Q, did I? Yeah, I did. Hit enter. And then it's going to total everything up. Which zone? So north had 800, south had 12, west had 16. Total miles, added them all up, and said west zone had the most. So there you go. And so that should be somewhat similar, right, to our other. Did I lose that? So in your case, right, you're going to be entering a D, E, F, or Z. So very similar, be doing the same kind of thing. You're just doing people, adding it all up. Very, very similar. Okay. And then we're doing this kind of the same logic. So that's going to kind of help you a little bit. Some things are a little different, obviously, in a Windows app than they are in a console app. But same thing here. You're going to be doing the ones for each person. And here we've got a delivery zone tracker. So this is one, same thing, right? So let me bring that one up here. Okay. So let's go and run this real quick. So here are how many miles was the delivery. Oh. And then I'm going to choose one of them. And it's going to, each time it's just going to go ahead and add them all up, right? North zone has the most miles at this point. South. And then let me do 1600 for west. So west has the most. I haven't actually done it where I did multiple though. Let me add that to south. Okay. Everything seems to be working there. Okay, looks good. What if I just don't put anything and hit north? It's just ignoring it. What if I put in let me put in something it's not supposed to have. Okay. It's not failing, it's just not doing anything. Better always to have some kind of error messages, that's okay, but it's not a requirement at this point. Eventually we will have to make sure we do that correctly. Okay. I went ahead and just left all labels. That's up to you. I don't care either on that. Obviously looks a little cleaner without having that, but all right, let's just look at the code here a little bit. How it's a little different. And so once again, we've got our class. Obviously, you come in here, and if you didn't set the name, whatever, this is going to just say Form 1, right? By default, it always says Form 1, I believe. So here we got our class level variables, north, mile, south, west. Um, and then here I also did kind of a separate method. You don't have to do things like this, but kind of for my purposes, it just seemed to make more sense, and it's kind of how my thought pattern goes. So, I have this process delivery method, right? And I'm passing in either south or north. Okay. Um, we could have created a constant up here and used that, right, and passed that in, kind of like what we did for the coin flip or the rock paper scissors. That's always could be a thing. You do 1, 2, 3, right? We wouldn't be doing random here or anything, but just a different way to do it. So basically, we're passing in a different zone, right? Either south, north, or west, right? Based on our clicking event. So this is never going to be an input thing. So this is always going to be whatever we defined here, right? And sometimes it is best to actually create these as constants up above. So if you decide to change names of stuff, especially if you've got it in your code in different places, right? Because here you're passing this in as south. What if all of a sudden you get rid of something? I don't know. I guess you get rid of the button, but you might decide to do something different. And this way you've already got north, and then you've got also north down here. Whereas if you just create it as a variable at the top, right, then you could always just change things easier without having to change it in multiple places, right? Same thing even here. You can have these being variables as well. But okay, I regress. So here you basically have a variable called miles, and then you're doing a so you don't care about, the reason we don't have miles defined up here is we're adding that to all of these, right? And after we add it to these, we don't care what the user entered, right? The user entered that. We're going to be using that within this method. Once we're done, we don't care, right? So that's why it's defined here. So here we go. We're going to go ahead and print that out to miles. Or set that on miles. So if this is basically saying, if this doesn't parse, just return. And that's why when we tested it, it didn't do anything. So if you put anything blank in there, so that's what's going to kind of happen here. Otherwise, what you could have done here, right here, is we just put it on the error label, right? Create an error label, and then you just would put it right here, right? And that would work the same way. And then, so this is kind of a different way to do this. I kind of like this sometimes. This is using the not, right? So most of the times we had it where if it was good, right? If it was valid, if it worked, then we had all our code. Here it's just saying, if this is not this, let's just go ahead and return, and we're done, right? So this is kind of another beneficial thing, kind of like when we checked for the quit, right? The Sentinel. So if we had that Sentinel, the quit, or the 999, sometimes it's best to check for that first. So that way you're not doing anything else, right? So this way we're saying, hey, is this an error? If this is an error, it's kind of a more beneficial way, I think, to do this, right? So we check to see if it's incorrect, right? We have invalid data. Yes, we have invalid data. And like I said, be a good idea to put this on a label saying, especially when using a win form, saying, hey, you didn't enter valid data here. Please enter valid data, right? Then we don't even have to go farther. We're done, right? And that's what you could have done here as well. You put this on a label, right? Right here. And then after you put on this label, you can just click return, okay? Because if you don't hit return here, what will happen in this case, if you don't do a return in this case, it's going to go ahead and start reading this other stuff, right? So you want to say, if this is an error, let's put this on the label. Right? Dot text, whatever. Probably shouldn't say that. There, just confuses things. And I put S. But, I'm just talking here. So basically, this doesn't exist. So yeah, it's not going to see it, right? But create that there, and then after you set it on there, you can hit a return, and you're out of this method, and you're done, right? You're not going to check anything else. All right. So if it's valid, then we come down here. We're going to add miles to the appropriate zone. Kind of the same situation, right? Once again, pattern matching. If you're going to do this, do it. Probably best to do it everywhere. But, like I said, you can try it. So this is going to do the basic thing. If the zone is north, if the zone is south. All right. Pretty straightforward on this, I think. And then after that, we're just updating our zone labels. So one thing I did want to mention, a lot of times are while loops. While loops work a lot better, kind of probably within console. It depends on what you're doing. I shouldn't say it, but within a console app, you can kind of do almost everything with a while loop until you decide it's time to leave it, right? Because a form's different. Where you enter some data, you might do something. You're going to come back to that form. That form's going to be updated with data, right? Usually on a console app, you just keep entering data until you decide not to. And then when you're ready to finish, you quit. And then it's going to kind of print everything out. So usually console apps are very good for having like a while loop, right? And then as long as you're in that while loop, it'll continue on until you leave it. Then you have everything totaled. Whereas sometimes with a WinForm stuff, you can constantly be updating that and seeing your totals just because the layout's different, right? So it kind of can work in a little different way. So once again here, kind of the same thing here. And calculating total miles, setting it on our total text. And then once again, we have to check to see which one had the most, right? Same thing as what we did in the console app. And then once again, it's always best to, make sure you got your else's, right? Because you don't want to, no reason to check this if this first one's true. If it's north, no reason to check this one, And then once again here, so if this first one is false, if the second one's false, then we know that this is the highest one, right? And then here we're just doing a clear and focus. So this will just clear that field, whatever's in there, and put the focus back in there. Okay, let's take a look here. So, all right. So that was you're doing sales, and I did the delivery zone. And the next one here is 5, which is lab 5, which you're counting the vols, right? You're counting vols. So instead of counting vols, I'm counting digital characters. So it's going to be very similar. You're just going to be counting vols. So I'm listing 0 through 9. So you need to list all the vowels, right? A, E, I, O, U, right? You need to list all your vowels instead of digits. So it should be pretty straightforward, I think. And so like this, just a WinForm app. So make sure you kind of really, read it carefully. I do have them highlighted, WinForm app, console, etc. Okay. So let's go ahead and take a look at that one. Okay. So here we're just counting digits. So basically enter some text here. Let's just run this. Obviously the form could look a little nicer, but that's okay. So entering some text. I'm just going to enter numbers and letters together, just for fun here. All right. So we've got 1, 2, 3, 4, 5 digits, right? So it's just going to count digits, and there's 5, right? So it doesn't count any of the letters. And I'm not don't know what'll happen there. Yeah, 0. That's what's expected there. Okay, so pretty straightforward for the most part here. So let's take a look at that one. Okay, so in this one here, we're in our class, so we don't have any variables we're holding on to, right? It's just kind of you click the button, everything gets figured out right then, and you're done, right? Here we're doing, so we got an on-click event for our account, and we do have a couple variables at the top of our method, right? But once again, these are only available within our method, but we don't need them outside of our method. So this is just getting the text from our screen, and we're starting with a digital count of 0. So now we're going to loop through each character in the text. So what we do is we take our text and we do .length, okay? We do .length on that, so that's going to tell us our length of our text, each character, okay? The 4s that you've seen before, a lot of times they were, like 10 or whatever. You had them precise numbers, right? Exact numbers. But here it's based on how many characters are entered into the text field. So in this case, we've, just depends on what you enter. So then what we're going to do is you're going to do you're going to get the current character using a substring, okay? So basically, it's going to grab the character. It's just getting the first character, which is always going to be just the first character. You get the current character using a substring. So right? And then it's going to grab that first character based on location. So the first one is going to be a 0, right? Which is the first character. Remember everything, and I know the students who've already took the JavaScript thing last semester. They've kind of been through this a little bit. A lot of things in coding and computer science, it's 0 based, right? So your very first item. So as you can see, we're initializing this, right? So that we're initializing this to 0, right? And so we were going to be starting at a 0, and so the first character in our string is at position 0. Okay, so the ones at position 0 is going to be we're going to grab it. Basically, we're just grabbing whatever's getting sent in here, right? So the first one depends on what then the second one. So this I is going to change. First time in, it's going to be a 0, right? Then we're going to go through our loop. When we finish our loop, it's going to come back up here, right? And then it's going to be 1. Then it's going to be 2, all the way up until our length of our text. Okay. And if you recall a for statement, right? Do you remember the parts of a for statement? Let me bring that up. Actually, I think it was a presentation that kind of said which one each one is, but it has it here. So basically, our first part, this first part here, there's always 3 parts. There's the initialization, the condition, and the increment. So the first part is the initialization, initializing a variable. Here's initializing to 1. In our code, we're initializing it to 0. Most of the time, I'd say it's usually best to initialize it to 0. There might be some situations where you don't. If you're counting numbers, right? The first number is 1, right? So yeah, you're doing that. Something really simple like that, yeah. When you're iterating through things, like the string, the string stuff, we're doing a substring characters, best to start with 0. If you're iterating through an array, which we haven't learned arrays, but we will soon, it's best to start with 0 because a lot of things, like I said, are 0 based. So here we're initializing it to 1, but it should, most cases you really want to initialize it to 0. That's the initialization. Next one is the condition, right? Here's your conditional part. Here is I is less than or equal to 10, and then your increment. So you're incrementing. So after the end of what you do, it's going to add 1 to that, right? It's going to add 1 to it, then it's going to check. It's going to add 1 to it, and then it's going to do this check, right? So this is just the initial thing, happens one time, right? You initialize this for loop one time, then once you go through and do this one time and you come back up here, it's going to increment it 1, then it's going to do this check, right? It's going to do this check. And it just continues, right? As long as I is less than or equal to 10, it's going to continue to loop until this condition takes place, and then it's just going to stop, or it won't execute anymore, right? Okay. Let's see here. So once again, we're doing that. So we've got a for loop, and we also have within our for loops, we have like two ones, right? We learned about a for loop, and we also learned about switch statements as well, right? This is using the older method of switch, so I should have left that up. So we probably should be looking at that as well. So here, the switch statement implements, so here it's the case structure. So yeah, so this is basically what we're doing right now in our code. Case 1, case 2, case 3, right? So as you recall, so you're passing in some value, some variable, right? Some variable. In this case, you can tell by, without even knowing the variable, obviously you're going to know what it is, right? What it's defined as. You can tell by looking at this, though, it looks kind of like an integer to me, right? Because the case is a 1, right? These are not strings or anything. These are numbers, right? So if an employee type is a 1, it's going to, the description set this. And then you always have to remember, after every 1, you have a break, right? So if you come in here on employee type and it is a 1, it's going to set that description. It's going to break out of here. It's not going to do anything more, right? If it isn't 1, it's going to go to the next one, which is 2, etc., 3. And then if it isn't 1 or a 2 or a 3, it's automatically going to set this and break out of there. And always remember, you always have to have a default as well. Okay. Now this was the same one. So this is the more traditional way. Either way is fine. Okay. I guarantee there's a lot of code out there that is like this, and I guarantee there's a lot of people writing code still using the traditional one. It doesn't matter, right? And like I said, though, if you're writing some code, for us starting out, whatever, if you want to do if you had 2 switch statements in your code, you want to do one way, one the other way, that's fine. But, long term, once you really start coding, you should, stick to it, be consistent in your code, right? So this is the more traditional one. And here's a switch expression. So basically you're doing the same thing. You've got an employee type that's obviously defined earlier before this switch statement. And then you're creating this variable yourself here. So you're saying basically, you're going to set this to one of these, right? And, it's much more concise, right? So if employee type's 1, make sure, you're using what they call the fat arrow key, but whatever. So the equal arrow, right? So for each one, and it's going to set it, and make sure you always have to have a default here, okay? Well, here you don't have to worry about a few things. You don't have to worry about the break, right? You don't have to worry about the break, and, a little more concise. You don't have to have the case name and all of that, right? Much more concise, just a different way to write it. Okay. I thought that was worth us spending some time. And since we're here, just real quick, where's our whiles? They're probably down below. Yes. Let's look at our while real quick. So I do want to review this again. Repetition is good. So test the condition. So a while loop, it tests the condition before executing, right? The body, right? So this may execute 0 times or multiple, right? In this case, it's going to do multiple because I starts at 1, I is less than 10, it's going to execute 10 times, right? Um, yeah. This is just showing here, if I starts at 11, if your value up here was 11, this would never execute at all, right? But this is just a regular while, which we were already using, right? We just had true in here, right? So you can have a true. If you had a false in here, that probably wouldn't do you any good. It'd never execute at all, right? If you have a false in there. So we, especially in our console apps, we had a true in there, and that's basically saying you just keep on executing this loop until you break out of this, right? And so that's what we did, and we used the Sentinel to check for it, and if we find it, then we break out. So just remember, if you ever have a situation where you have a true for your while, if you don't have a way to get out of it, it's just going to keep on running, right? So it'll be an endless loop. So it's possible, depends on your code situation. You could be, obviously these prompt apps, we just close the window and stuff. But sometimes if you have a program running somewhere, which we'll see later on, you can actually have a standalone program running, and if you do that, it's gonna be flying through that loop, and if there's no way to get out of it, it'll end up crashing something. Your memory will get exhausted at some point, right? But once again, that's a while loop, so you're always checking before. A do while loop, right? Test the condition after executing the loop body, always executes at least once. So here you're doing this do. This is a do while. I don't have an example of that in our code. It's not used as much, just because a lot of, you have to have some reason why you're wanting to execute that one time for that. And I would say it's not used as why, it's used probably rarely for the most part. I think the while loops are used a lot more, or few, or switch. A for loop or a switch, right, as opposed to a do while. So here you're basically doing you're always going to execute this one time. After you execute this, then you're going to then you check your condition, right? So this is always going to execute at least once. I know I've said that multiple times, but it's actually a very good, very popular interview question too. So, what's the difference, especially an entry level type thing, what's the difference between a while loop and a do while? And it's pretty much consistent through a lot of different programming languages, not just C#, same for JavaScript and others as well. So I won't say all, but so here we're just doing a switch statement on the current character, right? So we do our for loop. We're going to have a one single character, and then we're going to check if it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Yep. So basically what this is doing here, which is a little different, okay, it's just checking if any of these exist, if it's any of these, okay? It's a little different than we've seen where we checked for case 1, then maybe we set a value, like we looked at the example, we change it to management or staff or developer or whatever, or development, whatever it was. We change it and then we break out. So this is a little different in that it's just basically saying if it's any of these, okay, if it's any of these, go ahead and increment our digit count, right, and then break out of here, right? Otherwise, but you still have to, always have to include the default. Otherwise, then just go ahead and break out of here. So if it's not a 0 through 9, you're not incrementing our digit count, right? That's the only thing different. You're just breaking out. Okay, and then we basically set that on our string, and that's it. All right, and so that was number 5. So that's really about it. I'm not going to go through 6. 6 is a extra credit one, so you only are required to do 1 through 5. If you like to do 6, that's great. You can see that, remember we did do some things early on where we kind of had a different how we kind of formatted it, so you can kind of look at that maybe to help you a little bit with the formatting, especially when you've got these pipes and stuff like that. Um, you can kind of look at maybe what we did there to help. This one's pretty basic here, though. You probably could do it without doing too much formatting. But so this is obviously, I'm not going to go through this as extra credit. If you get to this, you want the extra credit, that's great. If not, don't worry about it. So that's about all I have. I will go ahead and push all of this code out to the repository. So that'll be available out there, and I will send an email with the URL for the repository, and then once again, you can just go into GitHub desktop and pull that, right? And just make sure you put that somewhere besides your own. Don't kind of get that confused or within a folder within your other repository. Kind of make sure it's outside of that, right? Your coursework repository. So that's all I have. And so, please contact me if you have any questions. I hope these will help you a little bit with all these different assignments. I didn't want to just kind of give you all the answers. And so these are kind of similar without doing it for you. So please let me know if you have any questions, and have a great day.